How's it going? Today we're going over test 1 and we're going over 6 problems. First, I'm going to start with question 1. Question 1 asks that we find the equation of the tangent line to the parabola y equal x2, x to the power of 2, at the point 4, 16. So, our very first step, we have to graph our point and to visualize the parabola. So we can draw our x-axis, draw a parabola, just like so, and then we have to find the point 4, 16. So we go 1, 2, 3, 4, and up here 1, 2, all the way up to 16. So right here is our point 4, 16. So now we have to draw the tangent line, which is a line that passes right by our point, just nearly touching it, brushing right past it. Just like that. Never touching, just by it. Next, we're going to use our slope formula, which is y squared minus y1 over x squared minus x to the power of 1, or delta y over delta x. Others may like to say that. So our first point right here is going to be x2, and down here is going to be x. So our y2 will be x2 minus 16, x for the x2 minus 4. Now to solve this, we have to break down our numerator, and this can be broken into x plus 4, x minus 4 over x minus 4. And this is when x is approaching 4. Now, x minus 4 on the top and x minus 4 on the bottom cancel each other out. So in the limit, when x is approaching 4, will equal x plus 4. We know our x is 4, so we just input that, and we get 8 for our slope. Our slope will be 8. And now we have to use our equation formula to find the line. This formula is y equal y1 minus m, or plus m, sorry, parentheses x minus x1. This is our point slope formula. There we go. That's the proper term. So now all we have to do is simply input our values once again. So we get 16 plus our slope of 8, parentheses x minus 4. We distribute the 8. You get 16 plus 8x minus 32. Combine these two terms. Get y equal 8x minus 16. This equation right here is the equation tangent to y equal x2. How's it going? Today we're going to find the 6 trigonometric functions corresponding to the angle pi over 6, which also is equal to 30 degrees. So our 6 trigonometric functions consist of sine, cosine, tangent, and then obviously they're opposites, so cotangent, cosecant, and cosine. Now, pi over 6. Pi over 6 is also equivalent to 30 degrees. So if we draw our angle like so, just like that. Right here would be 30 degrees, or in other words, pi over 6. Now, this side right here would be equal to pi over 6, which in other words is 3.14 over 6, which in other words is also equal to half. Because pi is so large and it goes on for so long that it's going to always. All right, now we have half. And now if we look at the unit circle and look at pi over 6, we see radical 3 over 2, comma 1/2. We found our half. And now down here on the adjacent is going to go radical 3 over 2. So we have our adjacent side and our opposite side. Now all we have to find is the hypotenuse. So to find the hypotenuse, we have to use the hypotenuse formula, which is c equals a squared plus b squared radicalized. So for this, it would be half squared plus radical 3 over 2 squared. If we put this into our calculators, we get 1. So our hypotenuse is 1. So our triangle is 1 for hypotenuse, radical 3 over 2 for the adjacent, and half for the opposite side. So now all we have to do is input our values. So our sine is opposite over the hypotenuse. So half over 1 will just be equal to half. Our cosine is the adjacent over the hypotenuse. So radical 3 over 2 over 1 would be radical 3 over 2. Our tangent is opposite over adjacent. So this one's a little trickier. Half over radical 3 over 2, which is equal to half times 2 over radical 3, which is equal to 1 over radical 3. Now, all we have to do is find our cosecant, secant, and cotangent. These are simply just the opposites of those. So it'd be 1 over sine of x, 1 over cosine x, and 1 over cotangent of x. And that is how we find the 6 trigonometric functions of pi over 6, or 30 degrees. If we look at our unit circle, this right here is just a small part of the unit circle. Our unit circle would be like this, and right here, pi over 6. And using the unit circle, we can find the values of any triangle. The 6 trigonometric values of any triangle. Let's move on to question 3. All right, question 3. Pregunta 3. This is asking us to find the limit of x when it approaches 0 of tangent x over x. Now, we cannot simply just input 0, right, because we get 0, and that just does not exist. That is a line, that is a function that does not exist. So tangent x over x, we have to rewrite it in terms of sine and cosine. So we know that tangent x, or tangent, is equal to sine x over cosine x over x. Now that we have this function, we simply see that it is sine of x getting divided by cosine of x and x. So we can rewrite this function into sine of x over x cosine of x. Now, we see, there we go. We see this right here. Sine of x over x is equal to 1. So we can rewrite this into 1 over cosine of x. And 1 over cosine of x, when the limit is approaching 0, is equal to 1. So the limit when x is approaching 0 of tangent x over x is equal to 1. Question 4. Question 4 is asking to find the value of the constant a that makes the given function f of x continuous for all of x. The functions that the question is asking us to solve for is 2x plus 3 if x is less than 1, and if x minus 1 if x is greater than or equal to than 1. So we'll start off with 2x plus 3. This is basically asking us what is the limit when x is approaching 1 of 2x plus 3. For this, we'll simply input 1 as our x, and we will get 5. Now, our next, since 2x plus 3 is equal to 5, we have to find a way to make ax minus 1 equal to 5 as well. So we know our x is 1, so a times 1 minus 1 equals 5. 1 minus 1, and we have to find the number that we can give assigned to a to make this function equal to 5, which is 6. So a is equal to 6. That is how you would find a constant a that makes the given function f of x continuous for all x. 5. Question 5 asks us to find the vertical asymptotes of the function f of x equals x squared over x squared minus 4. Now to do this, we are going to set our denominator x squared minus 4 equals 0. Now we're going to find the x values that we can input into this in order to make it equal to 0. So our two values are 2 as well as negative 2. So if we draw this function out, draw the parabola right here, 1, 2, negative 1, negative 2, and our function will look like this. With these two vertical asymptotes at negative 2 and 2, never ever going past it. And that's how you find the vertical asymptotes of the function f of x equals x squared x squared minus 4. Thank you. Question 6 is asking us to find the slope of the tangent line of f of x equal x squared at the point 3, 9. This question is very similar, if not almost identical, to question 1. So first, we have to graph our parabola, because it is x squared, like so. Now we have to find the point 3, 9. 3, go up, 9. Now, we are also trying to find the slope of the tangent line. So, we're going to use our slope formula, which is y2 minus y1 over x squared minus x1, or delta y over delta x. So, we simply input our values, x squared minus 9 over x minus 3. This can be broken down into x plus 3 parentheses x minus 3 over x minus 3. X minus 3 cancel each other's out. X plus 3 is what we have left. Now all we simply do is input our x, which is 3. So 3 plus 3, which equals 6. So our slope for f of x equals x squared at the point 3, 9 is 6.